All right, let's stare at part C. I have 1 over radical x and radical 1 plus x. So this is the application of this table here. So we have 3 kinds of integrals here, and I have to figure out which one is the most compatible with what I have here. So it's first of all, since it's like in the bottom we have 1 plus x, going back here, we have 1 plus x here in the bottom, right? So this looks to me like it's the sum of the squares, but you have to put it in that form first. So 1 over radical x, I'm going to put that in the form of like number squared plus variable squared, which is 1 plus radical x squared, and 1 squared as well, right? So, going back to that table here, okay. Checking those out. It could be the first one or the last one, we don't know. But we have to first call u to be radical x, because that's the u candidate for us after we put in the sum of the squares form, and see what's going to happen. We will see if it's the first form or the third form, or first integral or the third integral. So let's go ahead and call u to be radical x, or x to the power of 1/2, if you like, and look at du. That is 1/2 x to the power of negative 1/2, and that is in fact equal to 1 over 2 radical x, because x to the negative 1/2 is 1 over x to the 1/2, but that's the root x. And don't forget dx, right? There we go. To both sides, right? We have dx. All right, so let's go back to the original integral and then try to rewrite that in terms of u only. Okay? There we go. I have dx as well here, right? In the integral. Don't forget that. So here we go. So first of all, dx over radical x is 2 du, right? Because if you multiply this equation by 2 all the way, so it becomes like 2 du equals 1 over radical x dx. Boom. So here we go. 2 du divided by 1 squared plus u squared. Okay? That's good news. I can pull out 2 to start with. So this is du over radical 1 squared plus u squared. All right, so it looks like we have the form at the top, not the one in the bottom, because the one in the bottom has u extra outside the radical, right? So I don't have that. So I don't have it, so I'm going to go with the very first formula here in the list. So that is ln of u plus, well, you have plus minus, right? So I have the plus version of that, so I'm going to keep the plus version of it, okay? So this is the plus version, and this is the plus version. And this is how we write those formulas, right? If you go with plus at the top, then you have to go with the plus on the right-hand side of the equation, okay? So let me just copy this down. Here we go. I just copied that down all the way here. So now I'm going to back substitute everything. So, and don't forget the 2 here, okay? So I have 2 ln u, well, which is radical x, plus radical u squared plus a squared. Well, a equals 1 here, right? Because this is our a. So let me just write that down here for your own reference. A equals 1, so I'm going to put that back here. So 1 plus u squared plus a squared. Here we go. So u squared is just x, plus 1 squared is just 1, x plus 1, and plus c. Okay? I think this is the final form of the integral of 1 over radical x, radical 1 plus x. And I think we're done with all parts of this exercise. And what you can do next is to consider all of the derivatives formula in the form of integral formulas. What I mean by that is, like, for example, if you treat this derivative formula in the sense of antiderivatives, so you can just conclude that taking u to be x, So dx over x squared plus 1 is inverse sine hyperbolic x plus c. Okay, so you can always consider the derivatives formulas as like antiderivatives or integral formulas. So also when you try to use this table in the future, please look at these formulas in that regard as well. Okay, and this is sort of like a good generalization of these formulas, because you have in the bottom you have sum of the squares or difference of squares in one way or another. So, but please also consider these formulas in terms of integrations. All right, let's keep this video short. And I'm done with part C and with all the sub questions of the exercise. And that's it. If you have any questions or comments, please send those to my way. I'll see you in another video. Bye.